Hello friends, I am Kishore. Welcome back to Chennai Robotics Platforms Tech Talks featuring Electrofocus 2019. Electrofocus 2019 is the annual symposium of the electronic department of my college, Madras Institute of Technology. Now we are conducting many events where you can win cash prizes and internships in reputed companies, and we are also conducting workshops where you can learn about the technologies that are currently in trend on this decade. Okay, to know more about Electrofocus 2019, like the events we are conducting and the workshops that you can attend, visit www.electrofocus.in. Okay, now let's get back to the video. Last week we saw about embedded systems, which is one of the rising technologies of this era, and in this week we will be updating our knowledge with the technology which is known as Internet of Things or IoT. So let's get started with today's video. Okay friends, now this is the video for today. Now I'll run the program. Open the door. Close the door. Open the door. Close the door, please. Okay, now before getting into IoT, what exactly is a network? That's what we are going to see in this section. And if you are someone who is well versed with networking, you can skip this part and go to the timestamp mentioned in the description below. Okay, now network consists of devices which are connected together. Now let's say if my computer is connected with my smartphone. Now we have created a network which comprises of two devices, that is my computer and my smartphone. Okay, now why do we need a network? So we need a network to establish communication between two devices. Now even our landline phones, that is our telephones, are connected together, and even they comprise a network. Now that's known as the telephone network. Now I'll be using the term network very often, so I'll have a small notation n/w for indicating a network. Okay, so we have a telephone network. So now two devices can communicate with each other in two methods. One is known as the analog communication and the other is known as the digital communication. In analog communication, we will be sending waveforms, electrical signals, which will have varying voltages, and in digital communication we have only two state of voltages. One is the high voltage and the other one is the low voltage. So high voltage is mostly 5 volts and low voltage is mostly 0 volts. Okay, now most of the devices, current devices like smartphones and computers, work only on digital data. So most of our communication in this era is mostly digital, and some networks still use analog communication. So telephone networks use analog communication. Okay, now let's get deeper into the concept of network. Okay, so for digital communication between two devices in the internet, there are two things involved. One is known as IP address and the other one is known as port. There are two kinds of IP address, IPv4 and IPv6. IPv4 is a 32-bit number and IPv6 is a 128-bit number. So this has 4 billion combinations, and this has many combinations. It exceeds even gazillion. I don't know what is a gazillion, but it is definitely greater than gazillion. There can be like 4 billion into 4 billion values, or even more than that. Okay. So basically there are 2 power 128 combinations of IPv6 address. So we will be focusing on IPv4. Okay. Now let's say I am trying to access google.com. So I will be having an IP address and Google will be having an IP address. Now let my IP address be something like this: 100.1.5.6. So Google will be having a constant IP address all the time. My IP address will be changing every time I turn on and off my internet, but Google's IP address will be remaining constant for all the time. So Google service will be running 24/7. So it will be having a constant IP address. Currently, Google has many IP addresses. It has 64,000. There are 64,000 IP addresses for www.google.com right now. But what is an IP address? We know that IPv4 is a 32-bit number, but this 32-bit number is split into 4 8-bit numbers. So each will be 8 bits. Now 8-bit number can hold the values from 0 to 255. So currently a typical IPv4 address will be in the format like this. You see all these values lie between 0 to 255, and currently Google's IP address is anywhere from 172.217.0.0 to 172.217.255.255. So this will be constant, and these two numbers can be anything between 0 and 255. Now go to your Google Chrome browser and try something like this: 172.217.1.1 instead of typing www.google.com, and it will take you to google.com. Okay, now let's try it out and it will be interesting. So if you have tried out, now you will be knowing that we are using IP addresses almost all the time. It's like all the time, it's not almost all the time. All the time we are using IP addresses to communicate between two devices, and instead of typing 170.170 and all this stuff, we will be using www.google.com. So this will translate to an IP address which can be referred from DNS. Now this is like a yellow pages, and this is sent to DNS and it will return the IP address of Google, and you can use that to access Google. Now currently the IP address of Google is 172.217.1.1. Just write out. Okay. Okay. Now we have IP address. Now we will be having another thing called as port. So now to access HTML documents from Google, HTML documents are what is responsible for you getting like this. Now if you type YouTube in Google, it will return a web page like this. You will be having the word you type here, and all your search results will appear here. So how these appeared in your web browser is Google sent some instructions to your Google Chrome browser, and that instructions are what led to you seeing these in your web browser. Okay, I hope this is not confusing, but your web browser is retrieving HTML documents from Google. So to retrieve HTML documents from Google, we will be using something called as port 80. So this uses HTTP protocol. So port 80 is reserved for HTTP protocol. Now if I want to create a website www.crp.com, first I have to check whether this URL is not used by anyone else, and I will be having a server which will be running 24/7 like Google, and the IP address, let it be something like this: 120.0.0.1, and this has to be available first. And if it is available, I will link this DNS, I will link this URL to this IP address, and I will store it to DNS. And you can use this IP address and port 80 to view the contents of CRP.com. Now if I had used some other port, now let's say I use port 120 instead of port 80. Now if you try to access CRP.com, you will get an error because web browsers are programmed to access port 80, but you can bypass the web browser's instruction and you can try something like this: www.crp.com, and you can do something like this and then give this port 80 by yourself instead of the web browser. Web browser will automatically use this to access port 80, but that will be wrong if I use some other port, and you have to manually give the port number here. Okay. So but it is best if I am using port 80 because people who don't know anything about ports will be crazy if they are not able to enter www.crp.com. Okay. So now port 80 is used for HTTP, but we can do more with internet than just using accessing HTTP files. Okay, HTML files. So that's where Internet of Things comes into play. So So what is Internet of Things? Now let's have an example, like there are many houses in a Chennai city. Now let the houses be represented by circles. So there are many circles, many houses here, and each house has a smoke sensor installed in them, and there is a central fire station and sub fire stations in Chennai city. They will be represented by squares. Okay. Now let's say this house has caught fire. So the smoke sensor of this house will send a message to fire station. So now fire station, now while using HTML documents, Google was our server and we were the client. But now in this case, this will be the server and the smoke sensor will be the client. So the client will access the IP address of the fire station, and the smoke sensor will also have an IP address. Now instead of computers, even devices which are connected to the internet will be having IP address. That is the concept of IoT. Okay. So devices will be connected to the internet and they too will be having IP addresses. That's why we are moving on to IPv6, because when more devices are connected to the internet, we will be having more than 4 billion devices. So we need more bits to have more devices in the internet. Okay. So we will be using IPv6. So the client will be having an IP address, the fire station will be having an IP address, this will be the server and this will be the client, and it will send a request to the fire station. Now we are not using HTML documents, we will be using SOS signals to the fire station. So we can use something like port 400 for this service, IoT service. Okay, that is the concept of Internet of Things. Instead of connecting just my laptop and mobile to the internet, I am even connecting my sensors and the fire station's server to the internet. Okay. Now I have sent a SOS message to this fire station, and now this fire station will check for the nearest sub fire station to this house. This will be the nearest fire station, and now the fire ambulance of this station will reach my home and will extinguish the fire. But now there's more to this than it meets the eye. Okay. Now let's see. Now let's consider only these two things: the sub fire station and my house. This is the sub fire station, this is my house, and there are 4 roads which can be used to reach my house. There will be this road, there will be this road, there will be this road, and there will be this road. Now by seeing at this diagram, we know that this is the shortest path. But now what if someone had an accident here and there is a traffic jam in this road? So there will be many cars here. So now if the fire ambulance uses this road, it will be caught in traffic and things will get worse by then. Okay, so we have to take another road. But how can we know if there is traffic in a road? Now let's say all the cars in this road are using Google Maps. So Google Map will know that there are many cars in this road, and if it is somewhat greater than what is usually present. Now let's say usually there will be 80 devices in this road, but now due to traffic jam there are 160 devices in this road. So Google will know that there is a traffic jam in this road, and it will tell the fire truck to use this road instead. So even though this is longer than this road, there is less traffic and the fire ambulance can reach the house faster than this road. Okay, so now that is the concept of Internet of Things. By connecting dumb devices and sensors to the internet, we can do much more. Now this is just some small example. Now you saw another example in the beginning of this video where I sent a speech message to my laptop, and another device, that is my Raspberry Pi, used that message to open and close the door. Now Raspberry Pi and my laptop are not communicating with each other through wires. Okay, now they are not connected through wires. Now we are using internet to communicate between those devices. Okay, that's what happened in my case, and I'll get deeper into it. Now there were many devices which were involved. First I had my laptop, and I had my Raspberry Pi. They were not connected to each other through wire. They were connected to a common modem. Okay, let this be the modem. So these two devices were connected in a local area network. Now if I want to access Google, I have to use the global network. But now since all the devices are connected in my house, I am using local area network. So this had an IP address like 192.168.1. 1.1.1.4, and this side an Raspberry Pi. Now let this be RP, Raspberry Pi. So this side an IP address 192.168.1.103. Okay. Now this had a port 4000, which can be accessed by this laptop for communicating that open and close messages. Okay. So now I was using Google Speech API in a Python script. So this Python script had access to Google, and it sent my speech data to Google, and Google converted it into text and sent it back to my laptop, and that message like open the door is a string which was sent to Raspberry Pi through port 4000, and Raspberry Pi got that string and it searched for two words. If the words open and door were present in that string, the servo motor which is connected to this Raspberry Pi will open. Now if the words close and door were present in that string, the servo motor will close instead. Okay. So if you want to know about how the servo motor and Raspberry Pi works, I suggest you visit the previous video of this series, which was embedded systems. So now embedded systems comes into IoT. Okay, embedded systems and IoT are not different. Now they are the same, and that's why our series first started with embedded systems, and now we are moving to IoT. And these two will be having a link with our next week's video, which will be computer vision. Okay, so we'll be using computer vision, IoT and embedded systems all at the same time. That is the magic. Okay, now we are using many technologies to do magic, and if you want to learn about them, do subscribe to this channel. Okay, you have to. Okay, subscribe pannunga. Okay. Now what was happening exactly? There are two scripts which were running parallelly in two devices. So Raspberry Pi was the server, and my laptop was the client, and there was this modem here. So first this got the microphone of my laptop is a sensor, and it got auditory data from me. Okay, now that sensor's data was sent to Google, and Google's machine learning API converted it to text, and that text got transmitted back to the laptop, which is a device. Now this Raspberry Pi had an actuator, which is the servo motor connected to it. Now the text data got sent to Raspberry Pi, and that data was processed to send an instruction to a motor. Okay, so now sensors which were involved in this network is my microphone, and the actuator which was connected to this network is my Raspberry Pi. So we are connecting sensors and actuators to the internet. Now there can be many examples. Now let's take another example before going to the demonstration of my script. Okay. Now let's say there are many farms here, farmlands here. Now this farm is located in Tamil Nadu, this farm is located in Punjab. Now I'll have it PN. Okay. So now there will be sensors in the field of Tamil Nadu, and there will be sensors in the agricultural lands of Punjab too. So let this be S. Okay. So these sensors gather data like moisture, humidity and all those stuff, and those sensor data will be sent to an intelligence. Let this be the Indian Agriculture Board, IAB. Okay, oh, that's not the actual name, but let these sensor data go to IAB, and now IAB will decide the irrigation pattern and the seeds which have to be sown in these lands, and it will send those data to this farmers of these lands. Okay, now the farmer will be getting a message in his mobile, and let's say we have sprinkler irrigation. Now this device will be connected to the internet, and IoT will send a message to the sprinkler device. Now let's say for this moisture you have to be on from 6 PM to 7 PM and 6 AM to 7 AM. It will be getting information. Now this sprinkler will be getting information from the internet, from IAB, and irrigation automatically happens at this time. Okay, so by connecting sensors, actuator and many devices to the internet, everything can be automated. So this world is moving towards automation, and if you don't follow, you will be left behind and you will be struggling. Okay, so IoT is the magic of this decade. And now let's move on to our script, where we will be opening and closing the door using speech data. So in that case, my microphone was a sensor and the servo motor was the actuator. So sensors and actuators are being connected to the internet. If you have any doubts, leave a comment below and we'll see about that. Bye. Please open the door for me, will you? Please close the door. Open the door, please. Hi, can you please close the door? Bye. Hello friends, now this is the setup. So we have our servo motor which will act as the door, and it is connected to Raspberry Pi, and that's one of the only connections which we have in this video. In previous video we had a PIR sensor, but now we'll be using speech processing to open and close the door, and it is connected to micro USB power. And now you can see, now this is my computer and they are not connected to each other through wire. Now this is connected to my modem over there, and this laptop is connected to the same network. So basically both these devices are in the same network. So now this has an IP address 192.168.1.103, and this has an IP address 192.168.1.104. Okay, hello friends, let's move on to the code now. Now we have two devices. One is the single board computer Raspberry Pi, and the another device is my laptop. So my laptop will act as the client. So the client has a microphone attached to it, and the server will be Raspberry Pi. Okay, now let's see the code in Raspberry Pi. So I'm using remote desktop to connect with Raspberry Pi. Now my Raspberry Pi is not connected to my computer in any other way other than local area network. Okay, so now let's see the code for today. So we'll be having iot.py. So now we have GPIO pins library, we have a socket library, and now this code is what is needed to turn the Raspberry Pi into a server. So the server will be waiting for connections, and the server's IP address will be 192.168.1.103, and port 4000 has been set for communicating with other devices. So port 4000 is open and other devices can access Raspberry through this port. And now when a connection has been accepted, it will get printed on the screen, and now we are receiving strings of length 40 characters. And now let's see, in this code here you can see open indoor and door indoor. Actually door is the string which we will receive from the computer. So the computer can send any kind of strings like please open the door or open the door, and the door has to be open, something like that. So it will basically have the word open and door or close and door. Okay, so it has to be within 40 characters. Okay, so in that string we'll be searching for these two words, and if they are present, p.change duty cycle will get executed. So the server will turn like this. So p.change duty cycle 5 will turn the server like this, and that will be happening if close and door are present in the string. Okay, so if these two words are present, the door will close, else open and door are present, it will be, it's like it will come like this. Okay, so if I say bye, the program will get terminated in both the server as well as the client. So now Raspberry Pi is the server, and now let's look at the client's code. And before that, let's run the script. Okay, now I am running the script and it is waiting for a connection from another device. Okay, now this is our client program, and that was our server program. And now even our client has a library like socket, so it's required in both devices socket. So now we have another library, speech recognition. So this is the Google speech API library, so it will just record my audio and send to Google, and Google will throw back the text of that audio. Okay, so we are connecting to 192.168.1.1.3, which is the IP address of Raspberry Pi, and we are connecting through port 4000. And once that gets connected, this message will be printed on the screen, and we are setting the microphone which has to be used for collecting the audio, and then here a prompt will be given to us which will be asking us to speak, and once we speak, r dot recognize is a command. So now audio holds our audio data, and this audio data is sent to Google, or dot recognize Google. So it will be sent to Google, and Google will return a value, and it will be stored in text as a string. So we will be having useSet text, and we are sending the text via sock.send. So now sock is an object which will be used to communicate with Raspberry Pi. So we are encoding the string data and we are sending it to Raspberry Pi. Now, if I said bye, now the program will get terminated. And if the Google cannot recognize what I said, I will get an error saying can't recognize. Okay, now let's try this script. So now the server is waiting for a connection. Here, Raspberry Pi is waiting for a connection. And now I'm going to connect to Raspberry Pi. So I'll run this program. So speak. Open the door, please. So actually the door opened here. Now close the door. Close the door. Close the door. Open the door. Actually, I spoke lots of words like the length of this string is greater than 40. So I got an error. So I'll just speak properly next time. Hmm. Open the door. Close the door. Actually, the script is working here. That's what has happened. Okay, now let's see what happened here. Now you see connected to 192.168.1.1.4 and port something else. So this was the IP address of our laptop, and that's the program for today. So if you have any doubts in this video, leave a comment below and I'll clear it for you. So subscribe to this channel and we have more fun Python, Internet of Things, deep learning, all those content which is difficult to learn on the internet. Okay, bye. If you found the speech processing that I used in this video interesting, I suggest you go and watch Aditya Python YouTube channel. So the link for the channel has been given below, and do check out his videos, they are pretty cool. He teaches you how to use Python to send automatic mail to any email that you want to send mails to. And don't forget that Electrofocus 2019 is coming soon. It is from Jan 31st to February 2nd. We conduct many events where you can win prizes and workshops that you can attend to gain more knowledge on the current trending technologies of the world. Okay, so do visit www.electrofocus.in and don't forget to subscribe this channel where you will get to see even more videos related to Python and automation. Bye.